So I'm going to talk about continuously kicking ass, which altogether is about continuous delivery. Continuous delivery is basically an all-encompassing, at least the way I look at it, view of continually releasing, building, creating something, and not having like long cycles of, well, we go through and then we stop, and then we kind of ponder reality, and then we go to the next step. It's about integrating continuously so that you always know where you are, but not just you as a developer, but your customer, management, you know, if you have to, and all the other people that are included in the project have a better feel, have better confidence, have a better view of what's actually going on a day-to-day basis. Like right here, our iterations, bah. I'll admit though, sometimes you can get partway with continuous delivery and life gets so much better that you kind of stick to that anyway. Getting all the way there, like some companies, let's take Etsy for example, where they literally release production code from development multiple times in one day, isn't always necessary for every dev shop. But they're a working example of what you can do with continuous delivery if you really want to push it to the extreme. Before jumping into the technical tools of the trade, I just want to cover a few things about the priority of tools. Continuous delivery is great, continuous integration is great, all of these things are awesome, but if you forget that individuals are what we're building the software for, you got to keep that in mind. And the working software over big heavy documentation or anything like that, and collaborating with your customer, making sure they're actually getting what they want and what they need to do their job, whatever it may be. And when they need changes, being able to actually respond to that and do something about it. Whether it's add a feature, take away a feature, or build a completely new application. Tests are pretty fundamental, and pairing and communication within your team are fundamental. All of those things are vastly more important than the tools or actually doing continuous delivery or continuous integration. You got to keep that in mind when working with these things, because a lot of the time, you get playing with a tool, and all of a sudden, the next thing you know, you have 5,000 user stories. You're never going to get to all of them, but you're doing continuous delivery. You can kind of work yourself into a rabbit hole that way. So it's important to keep the focus on the customer and on the team, on the individuals involved. So I just wanted to add that right up front. Also, those 4 points you might notice are the Agile Manifesto, which is been around for a little while. So let's talk tools. Okay, maybe not all tools are great. Sometimes they have too many bits. I saw this picture, I had to put it in here. So let's not pull a Leroy Jenkins and go nuts. When we're talking about continuous delivery, one of the first things that we have to work with are builds. Just getting your software to build into something is important. In the case of our fellow feline friends here, they need a mousetrap. So you got to figure out how to get them some type of usable mousetrap to see if it even works. The tools to do that with, you have a wide variety. One of them is Maven. It's an Apache project. Another is Nant or Nant or whatnot, various names. I just remembered that this one existed today. I hadn't seen it in a while. Rake and Saki, which is not at Google Code anymore. It's at GitHub, like 98% of everything else. I had to chase around a few projects and found that. But there's a lot of build tools out there. Usually it involves writing some type of script, automating things in various ways, however you need to. And a lot of that depends on what you're building, whether it's an application that's going to run natively on an operating system or a web application. It could be a completely different set of things that you need to do. But once you get the build, then the cruise control cat is going to build your stuff. And that's where continuous integration comes in. And I like to differentiate a little bit between CI and CD, Continuous delivery I like to think of as the full spectrum, the full workflow, from the build to the end user, the customer getting a hold of the application and actually clicking a button or seeing a result. Whereas continuous integration I like to think of as the server that does a build, maybe runs tests, or does some other things like that. More of a tool-specific thing than the entire process or workflow. And when it comes to CI, again, you have a lot of choices. There's Team City, which will build a huge amount of things. I even found out recently that it will build iOS and Cocoa apps if you can find an Apple machine and attach it to the big cluster of things, in addition to like Java.net and PHP and Node. Not that I know how it's building that, but I guess it runs tests and it considers that a complete build. There's other tools like Jenkins and Travis. This is a pretty popular one, and I didn't get the image on here very good, but if you look right here, you'll see build status passive. Whenever you're on GitHub, if you look, usually on the readme.md file or something like that, you'll see these displayed. And what it is a little image tag, and it will show if your build is good or bad based on Travis running your GitHub repo build. So it's a pretty interesting open source project that a group of people have put together, and there's a lot of things that are running on it these days. I see these little tags all over the place on GitHub now. It's pretty cool. And then there's other ones. There's too many to list. I think I found 50 of them just looking. But some that I noticed that I liked, Concrete is a really minimalistic one that runs Node.js. Cruise Control is one that's been around. It runs various things. And Hudson is another one that also has a little bit of presence out there in the space. So you have your continuous integration server, and sometimes I'd say the greater majority of the time whenever I go into a dev shop or work with a team that have some type of continuous delivery idea, or they're working toward it or whatnot, continuous integration is about as far as they get, and they're like, okay, this is good, and then they might automate a little bit more of the deployment or something, but they don't go full breadth. Because really, when you get down to it, the big, kind of the big return, the big win at this point is if you can get the CI, you can, on a regular basis, as soon as a build is pushed, or as soon as code is pushed, you can know that your code is good, that your application at least builds. If you have tests, you have even more. But it's a great place to get to be able to have continuous feedback from your systems, to be able to communicate to stakeholders, management, other developers, or whoever. You know that your stuff is at least building. And if it's not, you know that you need an all hands on deck, stop, get it figured out. So deployment is kind of like icing on the cake at this point. Sometimes when people deploy things, like missiles, they don't go exactly like you might expect them to. The missile is obviously working. There is thrust coming out of it. But it's not going up anymore. And that's usually where the icing is pretty important, making sure your app is going to go to where it needs to be and be where it needs to be. So automating deployment is pretty important. However, there's not quite as many tools out there as there are for building and doing continuous integration. One tool that I've seen as of late is Octopus, which allows you to connect to various environments like UAT or test or production. And then this kind of helps you bridge that gap between your CI server and your endpoint. It is, however, it takes some steps. It's pretty nice, but it takes a little bit of work. And at this juncture, one of the technologies that has cropped up to kind of fill that last mile between, okay, I got my CI going, but now I want to make it easy and consistent and reliable to deploy on a regular basis all the time, and not have a bunch of overhead or weird process in place. Oh, I forgot this one. Larg scripts, that's another deployment thing where you just write tons and tons of scripts to automate stuff, and then you have to manage and maintain tons of scripts. That's a slice of one. I put it in here. I wish I had gotten all of it in. It's about 4,000 lines. So yeah, I was like, oh, that's perfect. And then I got 27, so it doesn't look too threatening. But just think 4,000 lines when you see this. So at this point, I was just going to show you real quick, because I have some working things that I've been working on at the company I'm at. I was just going to show you some live things. So here's a GitHub repo, pretty familiar. And there's an organization I'm working with called Iron Foundry. They allow me to commit code here, which is nice. And one of the projects, which is this one, it's basically a library that allows you to communicate with a web services API against any Cloud Foundry environment, which we can go into what that is in a little bit. But basically it's an assembly. It's going to go into something like NuGet, which if you use Rails, that's similar to gems or something like that. So we're going to put that out there, but we wanted to put it into a build process. And that's where we have our team city. And there is that process right here. So every time we commit code to the GitHub repo, this does kind of a polling. And every few minutes, I think it's based like on every 5 minutes, it does a poll. And if there's any new code, grabs it, it wipes out the space so that it knows that it has fresh code, and then literally starts to do another build by doing a clone of that repo. And like if I do that right now, that's basically what it's going to do. So theoretically, since the last one was a success, this one should be a success too. And there we go. A few seconds later, and we know everything's green still. No one's going to call me in a few hours and say that I need to fix the code base. One of the other things, speaking of the communication and back and forth with people in a continuous delivery process, we track things via the issues right here on GitHub, which there's not a whole lot in there right now. It's just me and one other guy working on it, so we mostly just verbally talk or talk via chat. We don't need a long historical backlog or anything like that. So they're listed here. But one of the tools when we do start to ramp up more developers and things that integrates with this is something called uBoard. And you literally log in with your GitHub account and you go to the repo you want to see, and you'll see all the issues. And based on their tag, you can have ready, working, test, over here a little secret backlog. And then instead of going through and manually changing the fields and such on those actual cards themselves, on this you can actually drag them over here. So it's a pretty nice little tool. It's open source also. It's on GitHub. You can fork it if you want to, if you don't like the way the scheme is or something like that. But it's all online. It's free. You go sign up. I think one day they might turn it into a paid-for service, but right now it's a nice little Kanban that's online. So when you have a bunch of remote workers and you don't have a physical Kanban, it's kind of the next best thing that you can do. So that's a little quick view of those things. And then dive back into this. Ah, it worked. That's so cool. Sold. Pass. Okay. So I just went over the things that we kind of use to keep good communication going on and everything with the uBoard, the Kanban. We try to keep continuous communication going on in addition to our continuous delivery. So we're always talking to each other, we're always chatting to each other. We don't send that many emails because it's better to just communicate immediately and keep things as real time as possible in many of these situations. You might notice, but might not notice, this is actually Thor. Looks pretty wicked. But yeah, so we're going to talk about PaaS for a second, which is that last model. PaaS stands for Platform as a Service. There's 2 open source projects right now that have been started that you can go grab at any moment. You can go install them in your environment. You can do it on site. You can do it out in some provider. You can put it anywhere you want it to be. It can be on physical boxes or it can be on virtualized boxes. Doesn't matter. One of them is Cloud Foundry. it supports pretty much every language and framework out there that people use these days. Case of Cloud Foundry, it did not support .NET, and the company I work for, Tier 3, started a project called Iron Foundry, which is that cool hammer over there. And they added .NET support to Cloud Foundry through extensions. So now Cloud Foundry supports the big enterprise languages like Java, .NET, and also a ton of the other ones like Ruby on Rails, Node.js, PHP, Spring Source Java, tons of other stuff. Perl, Erlang. I know probably 80% of everybody in here is like Erlang, right? Right? No? Okay. So, Cloud Foundry was created by a couple guys at VMware, and they turned it into an official project. Then VMware liked it so much that they turned it into a full-on effort, and now have, I don't even know how many. I know it's in excess of 30 people actually doing full-time development on it. They have a marketing department around it to message. They have advocates that go out and show people how to use it and run little like mini conferences and stuff and all that kind of thing. So literally, Cloud Foundry is unto itself like a company, really. There was even a rumor for a while that it might split from VMware and become its own company. It hasn't done that yet, but that rumor keeps sticking around. So anyway, it's a great project. It's got a lot of momentum behind it. The estimate also, there's some large entities in China that have started contributing to it. So the estimate is that, yeah, VMware is paying 30, 40, 50 people to develop on it. In China, there's probably 400 people looking at and or attempting to commit various features and other things and discussing the feature roadmap over there. So this has huge momentum behind it right now. The other project, which I did a horrible job of finding the icon because you can really see what it says. It's called OpenShift though. And it's by Red Hat Linux. And they bought an open source project, I guess about a year-ish ago, and they turned it into OpenShift. And if anybody's an OpenShift guru, please correct me whenever I make a mistake here. But I believe that they bought it, and then they basically were going to keep it in an open source project and expand on it and keep developing on it. So they have their own development team dedicated to this, and they've gotten extremely active in the open source community too, and have untold number of people developing on it. Right now, the core languages and frameworks that it has do not include .NET and some of the other ones that Cloud Foundry does. However, I have no doubt that at some point it will be completely in sync and parity with the frameworks and languages that Cloud Foundry supports. Because they're moving along at a pretty quick pace. They intend to catch up or surpass Cloud Foundry's nice little open source competition going on there. So those are the two big open source projects that you can take. You can put it in your own data center. You can put it in a hosting provider. You can download this code or the Cloud Foundry code, and you can put it on your local machine to try out. In the case of Cloud Foundry, it will literally, you can download a virtual machine that has every component on that one virtual machine that, you know, in a highly reliable environment, you would have distributed out to umpteen different virtual machines or servers or something like that. But they're all in one instance. It takes up about, I don't know how many gigs of space, but it'll use about 1 gig of memory, whatever processor, doesn't matter, it's pretty quick. And then you can actually test things by pushing to it. And you'll know it will work in a production Cloud Foundry environment because you're technically pushing to exactly the same thing. It just happens that they're all in one box. So very easy tooling to download, to set up, and then try out on your own. The other PaaS providers, which cover that last model, and everybody here is probably more familiar with some of these, like Heroku, right there in the middle with the cool H sign thing. They've been around for a while. They started out as a Ruby on Rails PaaS provider. They were kind of the first to market where their whole philosophy was simple as can be, you push it, boom, it's going to work. In the story, right? And since then, they have expanded to Java, Node, and I think some other languages. I don't know off the top of my head. Then there is Engine Yard. AppFog's kind of a newcomer. This one you can't see barely is actually a dragon, and that's App Harbor. They started out as, they made no secret of it. They called themselves the .NET Heroku, and also used to say that they are Windows Azure done right. So now also, just like Heroku, they support .NET, but they also support Node. So one of the things that you see with most PaaS providers is the expansion into other languages and frameworks. Windows Azure has also been working on that. They have great Node.js support now. I actually think their Node.js support is better than their .NET support, which is kind of a funny irony. AppFog actually uses Cloud Foundry as their base, that open source project I was just talking about. They support as many languages as Tier 3 because we use the Cloud Foundry also with the Iron Foundry. So we have everything AppFog does plus .NET. So that's just an idea of the PaaS providers that are out there. There's one other company that does cloud computing, AWS, but they won't actually say that they do PaaS, but they have a technology called Beanstalk, which is very, very similar. You say, you go into your IDE or you go to your command line or whatever, and you say, I'm going to deploy this app out into the environment. And you never have to look at an operating system. You don't have to think about where is this going to end up or whatever. You just say, I want 15 instances in, well, I guess you do think about, well, I'll put it in East 1 or in Oregon or California or whatever the data center is that you push to. You say how many instances and then you push. It's literally a 1, maybe 2 or 3 step process. Very clean, very easy. So that's the providers that take that last mile step for you and take you from where you're like, okay, I know I have a building application, got my green light, now I want to actually see it. I want to be able to have it in UAT or QA or test or a dev environment or production, say, in the case of Etsy, where literally just within a short period of time go through their test and then boom, right out to a live production environment. Very easy to do with all of these companies, the way they set it up. And in the other case, if you just go get one of the PaaS toolings, you can set it up in your own environment, like if your company doesn't want to use a public provider. So lots of options there. So I'm gonna attempt to do a demo, even though I think I broke my app a little earlier. So I'm pretty notorious for it. And I'll show you how easy it is to do a PaaS deployment. All right, what's the shortcut key? Bigger? That one? Oh, yeah, it is. Cool. So I'm going to deploy an app that I know is actually broken, but just so you can see how quick the process is. So I'm going to go in here. This is a Node.js application. It's pretty standard default stuff. I just opened that up. I just wanted to show you that it is indeed pretty standard. You get you an Express server set up, you set some properties, and you start the server, which is generally what you do with Node, and then you build out your application with various things. In this case, I used Express, so I have a views folder, routes folders, which kind of acts as controllers. You end up with kind of a typical MVC pattern like you do in Ruby on Rails or .NET MVC. So I'm going to look at where I'm pointed, and I am pointed at Tier 3's Iron Foundry sandbox space, which anybody can get an account here for free. So if you're interested, ping me afterwards, and I'll get you hooked up. Uh-oh. What?
Luke was upgrading once this evening.
I know. That's why my app broke the first time. The nice thing, though, was I had continuous communication with him, and as soon as my app broke that I knew worked, I said, hey, Luke, is something... And he goes, oh, yeah, hold on, I'm updating it. So, yeah, that helped reduce my stress a little bit. So anyway, so I've targeted that point so it knows which cloud PaaS environment I'm trying to deploy to. Then I'm going to log in.
password. That's always a cool moment. And then this is the really difficult, hard part of past technology. So you see there's some parameters, but I'm just hitting defaults, hitting the enter key. And then it'll usually take a few seconds to bundle it up. And it does a diff. You'll see that 10K. My app is at least 30K. It does a diff on whatever you have, whether it's a Ruby on Rails app, PHP, .NET, or whatever. Even with the built applications like Java, it'll look at that, and if your files that you've built are different, then it will take those different ones to push up. Otherwise, it leaves the stuff that's not different and just pushes the change. So generally, once you've done, like with a big app, say you have a 300 meg web application for whatever reason. The first time you push it, it'd be 300 megs. But then as you push diffs, it would probably be, 20K here, 50K here, maybe a meg, whatever. Saves you a lot of trouble, down the road as you're doing this. So the starting application part is what's going to be broken, because it won't actually start the app for whatever reason. But you can see how quick it staged it, uploaded it, did all the little things that it needed to. There's the variables up there that you can set, which is you can set the memory reservation and the instance count. With Cloud Foundry environments like this, you can set that as high as you want. And if you don't have the resources available, it will just tell you that they aren't available. So you can expand the backend as you see or need based on your requirements. But as far as this is concerned, you just ask for it. It's going to give you a yes or no back if it has it. In most environments, like say you're pushing app fog, for instance, you're going to get the resources. End of story. They automatically spool up instances and things whenever you push out there. So in those types of scenarios, like if you're not managing your own Cloud Foundry environment, all that stuff's taken care of for you. So that gives you that idea real quick. And then I just wanted to show one other bit. So if you have, oh, that's awesome. It shrunk. So, where's file? Yeah, it's too far. There it is. So if I make a web app real quick, there we go. New, yeah, that'll work, project. So if I just make a new web app and call it, let's use .NET and EC3, and then stuff. And yeah, that's wonderful. Internet app. Build a test project. I'm being good. Okay, so that's there. And there we go. So if you right click, over here, there's literally there it is, push Cloud Foundry application. And it will let you pick your available Cloud Foundry environment. So if you don't like the command line, in the .NET universe, there's this plugin for Visual Studio. In the Java universe, there is a plugin for Eclipse. I hear rumor that there's going to be plugins for other Java environments like IntelliJ and things like that. So if you don't like command line, you can stay away from it. There are options for that. If you like command line, the VMC is definitely, it provides all the interface capabilities here, and it just interacts with your folder structure of where your project is to deploy. So let's see here. I'm going to close that now. And let's see here. Play slideshow. No, I'll go back to the slideshow. So the last thing I want to talk about is a little project to extend Cloud Foundry. And again, it's that last mile bit. And the project is called Thor. Find the thing. actually seen that. Okay, so again, I found like an actual wicked looking picture of Thor. He usually looks just very happy, but I dug these up. So one of the projects that we've been working on under the Iron Foundry extensions, under the Iron Foundry organization, we extended the Cloud Foundry environment to .NET. We've also been working on a project called Thor, and it's basically Thor is Thor Odin's son. He's the god of thunder and the holder of Mjolnir, which is the hammer. So just a little background there so everybody knows who Thor is, just in case. Yeah, so he's that guy with the hammer. The project that we've been working on is 2 applications. They're both completely open source, and they're all about that last mile segment between like your CI and getting it deployed to a PaaS environment, so that you can clean that last little bit up, and you can always have things sitting there in production or in UAT or dev or test and know that that is basically a reliable fact that it will be working in production when you get it pushed to production. And these apps interface with the PaaS environment if you're using Cloud Foundry. So now I'm going to show a quick little Thor demo. And as I do this, I will say these apps are in hardcore alpha mode, so they break a lot. So I just showed you via VMC the one app, or the app that I attempted to push. And this is the Thor interface, and I have 2 clouds in here. I called one of them Robotech because I like Robotech. If you go in here, it shows you the active applications. In this case, that's an active application, and that one that I just pushed, which didn't work so well, shows up like this, where it says 0 memory is allocated. So if an application doesn't start, it's not going to have memory allocated to it. It's not going to have an instance count really added to it. It's just going to show up as kind of a dead application until you can actually get it started. It's a little frustrating because then you have to go kind of chase down the logs and everything, but at the same time it's also kind of a saving grace when you're working in an environment where you're going to get charged for the resources when they're used. It's nice to know if your deployment fails, you're not getting charged for it. And it might cost you the 3 cents or something, you know, for the instance attempting to start, but then it's going to automatically be, it'll kill it, and it won't be sitting there running. So these are the different applications. I'm going to look at this one, and there we go. So it shows a little bit. It's using 2 megs on the disk. 64 megs of memory is allocated. These number stats are a little funky right now. They need smartened up. But you can go back and forth. You look at your individual clouds, your individual applications. And then since I have 2 clouds here, one of the neat things that you're going to be able to do with this is you'll set up an application and you'll tell it the directory. Like right here, I have this application, Node.js_cloud founder. And that's an application. And if I want to deploy it somewhere, click this. I can pick one of the existing clouds. I can give this specific deployment path a name, deployment to Macross stuff. And this, I think, will actually, yeah, it gets an error code back because it's mocked at the moment. But it'll deploy out, and then the deployments will list here. And the idea is, if you have your applications deployed to, say, AWS and Windows Azure and AppFog, and you have Cloud Foundry environments set up there, and you have one deployed to Tier 3, and all these different places, and you want to see what's going on with them, you want to be able to deploy to them, and you want to be able to change resources as the day goes by, or maybe even at some point auto-scale things. This application will be able to do all of that. We're getting really close. I mean, this is basically, a bunch of odd weeks of work. We have one that's going to be available for Windows 7 also, and we're working on one for Windows 8. So it'll be native apps for pretty much every OS you can think of for 98% of the population. If you're using Linux, use the VMC. But anyway, it's another easy way, and that's kind of been like my baby as of late.
that I've been working on with the team to put this together against Cloud Foundry. So that's pretty much my wrap up. And the Team City environment, the GitHub, the U-board, all that stuff that I was showing you is what we're actively using right now to build this. And like I was saying earlier, this is all open source. So if you want to contribute, if you want to get involved, if you want to check out Cloud Foundry or Iron Foundry or any of these things, if you just want to, come and sit around on the email list or whatever, feel free. We love any type of input, whether it's code or just telling us that you think it looks funny and we should change something. You're the customer, we're the customer, everybody's the customer in this situation. So we're looking for features, thoughts, whatever. So I can sync up in a timely manner. There we go. I'm Adrian Hall. That's my blog. This is Tier 3 where I work. This is the project where Thor is and the .NET extensions for Cloud Foundry. This is the Cloud Foundry project. That's my Twitter and that's my app.net. So thanks. And if you have any questions, I'd be happy to answer them.
Yeah, a question over here, Adrian.
Yeah, so just so I'm understanding it correctly, so would Thor be a tool that's useful for pushing to any of these, for any other PaaS vendors like Roku?
Not Heroku yet, because they use a proprietary SDK, API, whatever you call it. As things kind of sync up a little bit, there's no reason we won't extend it to do that, right? And it's open source. So, if you're like, hey man, I want to use that app to push to Heroku, by all means. I mean, I'll take a pull request like that. Pending, of course, it doesn't break the application. But yeah, so it's totally open. And at some point, I imagine that we will probably support way more than just Cloud Foundry. Especially like with OpenShift gaining momentum and them being completely open source too. There's no reason why we wouldn't, support something like that. So just a matter of time, just a matter of being able to, put forth the effort and write the code.
And is Cloud Foundry what I would use if I wanted to set up my own PaaS?
If you want to set up your own PaaS environment internally, you would use Cloud Foundry, or you could use OpenShift. I don't know much about that one, but Cloud Foundry's been around. It had its first birthday in April of this year, so it's probably one of the oldest ones that you can take and install in your own environment. And then, of course, there's all the other public ones. Some of the public ones, like Tier 3 where I work, we use the Cloud Foundry base and the Iron Foundry base to build our PaaS, which we call Web Fabric, and then AppFollic has one also. So there are other public providers that use Cloud Foundry. So the application in that sense will work against those flawlessly too. Cool. Yep.
What advice would you give someone who doesn't have any problems to solve that would necessarily need the cloud, but really wants to get cloud experience?
Build the app and just use it to push stuff.
Okay.
Right, push Hello World applications, I don't know. Just whatever.
Gotcha.
And the app would be a good experience to, have needing to interact with cloud environments. You become familiar with the fact that, well, they're geographically dispersed. Sometimes you might push something to 2 different areas, and then all of a sudden you're immediately in a situation of, okay, how am I dealing with session state between these 2? What happens if I have a bottleneck of one database? Or do I have 2 database clusters over here and here? Am I replicating? I mean, you run into all sorts of rather interesting problems to deal with really quick, because right out of the gate, no matter how simple your application is, you have to start thinking big when you deploy things into a cloud environment like that. So just working with the app, just playing with Hello World applications,
Really?
Put Hello World in a session state and then try to deal with it across 2 geographic regions. That's an idea just for fun.
And to reiterate, there's multiple ways that you can play with this stuff for free. As Adrian said before, you can download a virtual machine of Cloud Foundry. So you can just run it totally disconnected on the bus somewhere, play with it. That's free. If you want to do .NET apps, you can download the Iron Foundry extensions, and that's in another VM, and you can run both of those locally on your machine. If you don't want to mess with VMs, both Cloud Foundry and Iron Foundry offer free sandbox environments. They're not supported or guaranteed uptime sorts of environments. They're just, hey, try it out, but you can get a free account to check that out. And then when you're ready to go to production with a real app, then there are multiple providers who will be happy to take your money and then give you guarantees about reliability and geographic distribution and all that stuff.
Yeah, and like Eric was saying with the Iron Foundry account earlier, our cohort Luke, who is in Spokane, was updating it with some of the latest bits. So it was kind of rolling some of the instances down, and I had attempted to do something at that exact moment. So as some were coming up and some were going down, my app was dying. But like he was saying, we're not providing a guarantee of uptime or anything with Iron Foundry, but we're working to keep it updated every day with any of the new bits that are being pushed to the projects. It provides a great sandbox space to try out, .NET, Spring Java, PHP, whatever you want to push up there. And there's tons of documentation on cloudfoundry.org, ironfoundry.org, and every day there pops up, a half dozen new blog entries on how to do this cool thing with, Cloud Foundry or something like that. So it's a growing community, and as it grows, there's more material, more capabilities out there, and it just keeps getting bigger. It's cool stuff. Yeah.
I have a question about how you deal with different environments, like different dev, test, whatever environments before you push it out to production. Do these things all live off-site, or can you have a local copy, or doesn't it really matter? Or
like with the apps, or are you talking about the actual PaaS environment? Because let's take an example, right? And I hope this will answer the question. Say you take the micro Cloud Foundry, and let's say you're writing Node.js or whatever, something on there. You take the micro Cloud Foundry, you run that VM, and you're just doing your local pushes. Kind of like you're just deving against something locally just to see what it's going to look like, kind of do some layout or whatever on, say, a web page. There we go. So we're building a web page, Node.js, deploying it all the time. Because you're deploying it to that micro Cloud Foundry instance on your local machine, when you turn around and say, VMC target the new location, it'll work. And what that new location would most likely be, like let's say you're set up in an enterprise and they're going to dedicate X resources to a test environment for Cloud Foundry, a UAT environment, and then a production environment. They could technically put all of those in one Cloud Foundry environment, install a single cloud controller, which you can have failovers. It can become very complex, but let's just say you have a single point that you're going in, and that cloud controller kind of communicates and handles all of these instances. So you can do one that way, or you can set up a different name to point at different environments. So you have completely autonomous environments, or you can run it all under one thing. Because the deployment method that it uses is duplicative. It's always being done in the same way. I like the way the AppFog environment, which is a completely public-facing Cloud Foundry setup, the way that works is literally they have a central point that you go in, and then your deployment is based on whichever environment you pick, because you can pick your provider with them. You can pick AWS, Windows Azure, HP, and somebody else. So based on your provider, you get that single point where you point to and say VMC target, or with the app, you put in that URI, and then whenever you push to that environment. And you would set up like one app, say your test one, you would just call it test.api.something cloudfoundry.com, and then uat.whatever, and you would kind of subdomain prefix it like that. So if you have one environment, that's the best way to do that, and they keep it multi-tenant, software-based multi-tenant. So it stays segmented. Like if something breaks here, if you push it to the next one, it's going to break. But that's basically the ways you would set it up. At Tier 3, the way we do it is you literally get an autonomous Cloud Foundry environment for every environment that you want to set up, and it's physically multi-tenant at that point. So does that kind of answer the question?
That helps.
Yeah. So that's really one of the beautiful things about virtualization and cloud environments that are hosted like that is you can duplicate tests to whatever without worrying about, well, what's the weird inconsistencies. I think the really traditional way to do that would be, well, I've set up this one machine, and then I set up this other machine, but now I've forgotten if I've patched this machine. So it removes a lot of almost entirely removes the operating system management and allows you to focus on building the application, which in business speak, keeps you in your primary business domain, right, versus doing a bunch of other things. So, yes?
What about if you're deploying to a Windows environment or a .NET app, is there issues as far as like licensing the operating system? How does that?
Always.
Yeah.
Okay. This could be a meeting unto itself. So like say you have SQL Server and you have, you're using the ironfoundry.net extensions, right? So you've installed it locally. You need to make sure that you have taken care of your licensing. The way we usually set up Iron Foundry is on a Windows core, server core, to keep the size minimal. We don't need a lot of UI because everything's going to be managed for you once it's available to the Cloud Foundry environment. So you license a minimal Windows server basic or whatever it's called versus like super duper data center Windows. And then say you deploy a SQL Server database. When you deploy that database, then you're going to have to consider your licensing based on what you're doing with the database. So if your database balloons up above the SQL Express allowed size or whatever, then you need to license it appropriately, and all the standard things come up.
Okay, I guess I kind of sorry if I can continue, but I guess I kind of misunderstood how like Cloud Foundry works. I kind of thought it'd be like something you install and it sort of has like VMs, which are like instances of the machines.
It is VMs.
Okay, but the SQL Server doesn't run within those VMs.
It does.
That's interesting.
Right. It gets sketchy because you can do VMs, or you could, if you really want to do like you want to install it from code, because it's all open source. You can go get it, right? If you install it from code, you could go put it on a machine that's just running the operating system directly, right? It's really up to you how you want to do that. The easiest way though is to use the micro Iron Foundry instance, and when you get that, that's using all free bits as far as I know.
Well, yeah. If you download the virtual machine, the demo environment for Cloud Foundry or Iron Foundry, what you're going to get is, in the case of Iron Foundry, you get a Windows VM that's running an unlicensed copy of Windows with a trial activated, and so it'll be good for 30 days, and then you have to throw it away and start over again.
Okay. Yeah.
If you want to set up your own environment in-house on your own hardware and run it for real long-term, then you have to think about licensing and all that stuff. If you don't want to deal with that, then you go to one of the many providers who will take care of that under the covers. You don't have to worry about it. You just say, I want a SQL Server, and they say, here you go. And the licensing is just built into your monthly subscription fee.
Yeah. So that's the easiest way to deal with the licensing, because then you don't actually deal with the licensing. You just pay it, and off you go. But yeah, whenever you're dealing with this stuff locally, with any licensed product in that case, in the end, at some point, you're going to have to deal with the licensing costs, or licensing thinking, I guess. So you got to make that decision. Everything else, though, is free. So any other questions, thoughts?
I have a question about. I think everyone is sold on continuous integration, right? But that little last step of continuous delivery, continuous deployment,
right?
There's kind of a psychological barrier there for a lot of people, not
there
just
is.
Management, but developers.
I would expect it to be kind of scary. For a lot of places it is. Etsy didn't just overnight go, oh, we're going to deploy every hour. That'll be fun. They kind of got there through a little bit of confidence building.
So
By
how do
deciding,
you-
your gates are good. Your tests really test stuff. Your verification mechanisms, whatever they be, are actually verifying that when your site goes live, it doesn't just go up and then fall over. Another company that does, I don't even know how many deployments a day, but like Amazon.com, they put new bits on there every, I don't know how often, but like you could be doing a transaction, and they have such a high confidence level that they deploy something, and they don't lose transactions. I mean, you might not see your whole cart immediately, or you might see some other little weird glitches happen here and there. But as far as transactions concerned, they have no trackable evidence that transactions ever get messed up, and they do pushes to production all the time, every day. And yeah, I mean, it's scary stuff, especially if that's not something you've regularly have done. But just getting to the point where you say you can push to UAT and have users go play with your stuff on a regular basis. That's a big step, and you're halfway there right then. You're not far away from it.
I'm wondering how long something as complex as Amazon, how long from the moment that somebody pushes, commits code into GitHub till that's actually deployed. It goes through UAT.
I don't know if they push anything in GitHub, but I often gripe at Amazon because I say they use tons and tons of open source, but they won't admit to contributing to it or using it. I'll just say that I know that some of the things that they push literally go to production just a minute or two after they push it. Of course, internal repos and such. But, Amazon's one of the weird cases, and so is Etsy. I mean, a lot of places it's fine to, what's the real need to push every hour to a production site? I mean, if your production site's up and running, the real key is just to make sure that when you do it, you can confidently do it. And things don't fall over, and you can get those changes up there. So even if you're doing that part, that production part, once a week or once however often, so that it makes your customers happy or your users happy. The main thing is just that last mile, being able to reliably recreate that scenario. And with pass tooling, it's super easy because you've simplified it down to the minimal essence of application, deploy. That's it. You're not in there tweaking knobs. You're not in there making 500 different configuration changes every time you do a deployment. There's definitely little tweaks. When you are getting into a more complex application that you have to still think about, like, oh, is my database being pointed at the right thing? Like in Rails, you got your dev prod. It knows where it goes. It knows where to point to things. Like in .NET, you got to make sure that your config is going to morph or change or have the appropriate settings for, dev versus prod. And as long as you do those little tweaks and everything as you're developing an application, you'll be able to seamlessly do that and just confidently deploy all the time. So.
Well, then, and the value of deploying every hour is that when something goes wrong, you know what's something that changed in the last hour.
Yeah. The other thing is, and I know there's not too many companies that do this. I know CloudBees, which is kind of a Java pass. I didn't mention them because I honestly forgot. There's so many of them these days that I get distracted by them sometimes. But like CloudBees and AppHarbor are two that I know that actually have CI built into their deployment, so that it not only would you set up your CI server locally, to work on stuff, but it happens at deployment to production time too. So if it